Okay, so the next part of this video is going to talk about horizontal translation. So on the left I have again a basic parabola, and we're going to compare that to the graph of x minus 3 and the quantity squared. So if you've never graphed this before and you don't have a graphing calculator, remember guys, you can always make a table, right? It doesn't take too long and it can get you out of a lot of jams. So I just plugged in some very simple numbers. You can use any inputs you want. If I put in 1, I'm going to get 4. If I put in 2, I get 1, and 3, obviously I get 0. And then I just took those points and I graphed them right over here. Right? So if you were to keep on making a table, this is what your graph would look like. So if you look at the blue compared to the red, you can see that it clearly shifted over to the right 3 units. Right, so it's not a coincidence that you see minus 3 right here, and the graph shifted to the right 3 units. Right. So then what I did after that is I said, okay, well, what if it was an x plus 3? So before it was x minus 3, and it went to the right. But now I have x plus 3, so I guess this means it should go to the left. So when you make your table and plot in your x values and graph your points, you'll find that that's exactly what happens. So I know that's going to be kind of confusing to accept, but when you see plus inside your parentheses, that actually indicates that you move left. And when you see minus in your parentheses, that indicates that you move to the right. We will talk a little bit about why that happens later, but that's something that we kind of save for a little bit later on. We just want to work on memorizing the rules at this point. Alright, so what I'm going to do is I'm going to actually pause the video and do up the answer key real quick for these. The idea is that you should be able to either make a table or use Desmos or your graphing calculator and graph these and then compare them to their parent functions on each coordinate plane. So we'll see how that goes. Okay, so these are the graphs that you should have. You can see the red would be the parent functions and the blue are the transformation functions, and we just want to kind of make sure that the rules kind of match up with our graphs. So for this one, because the minus 4 is in the bottom with the x, we treat it as if it's in the parentheses with the x. And when you have a minus or a plus in the parentheses, that indicates horizontal changes. All right. If they had put the minus 4 on the end, that's your cue for a vertical translation. Right, but that's not the case. So if we're moving left to right, that would be the vertical line. So we shift that over 4 units to the right, and then this other one stayed the same, and then we go ahead and trace our new line. So we would go with the blue curves for the graph of that transformation. We had a basic absolute value function. If you notice, the plus 2 is inside the bars, which indicates left or right. Because it's plus, we actually go left. So the normal tip of the V is now to the left, and every point would shift 2 to the left. Let's see letter C. We had a square root function. The minus 3 is inside the root. So that's the same thing as being inside the parentheses. Right? So that's, again, horizontal changes. So we're going to shift our normal points to the right 3 spaces each, and that's our new graph. Letter D is wonderful because lines are so simple to do. So yes, you could take a basic parent linear function, shift it to the right 1, and then it is a vertical stretch by a factor of 2, which means your new slope is 2. Or some kids are like, well, can I just change this to 2x minus 2 and graph it that way? And yes, that's why lines are so beautiful, because we have many ways to deal with them. Let's see letter E. We had a parabola. But the plus 1 is inside the parentheses, which means we're going to shift left 1 space. So I take this point, move it to the left 1. I take this point and I move it to the left 1. I take this point, move it to the left 1, and so on. And then letter F, we have a cubic function, which looks like my red function here. I plotted 3 points. I did 0, 0, 1, 1, and 2, 8. So I kind of did a table in my head. And because the minus 4 is inside the parentheses, I know I'm going to shift it to the right 4 units. So You can see I took each of these dots, moved it over 4. Took this dot, moved it over 4. This dot over 4. Right. So those are some little cheats that you can pick up on so that you can save yourself some time. In my third video, I will actually go through A through D. That way this video isn't too long.